Hello, good morning everybody, good afternoon everybody, welcome everyone. My name is Vishvadeep and I welcome you all on Unacademy Computer Science Channel for unlimited learning. If you are seeking for any kind of computer science solution, then this is the channel where we fulfill all your requirements, including your gate preparation, semester exam preparation, including your placement preparation, including the machine learning training too. So this particular Unacademy Computer Science channel is overall package for all of you for your computer science related learning. We are going to discuss about previous year gate questions in this particular session, and that is too on the tree data structure. This is the part number 3 of the same, and in this particular session we are going to talk about how you will solve the questions of gate on tree data structure. So it's not only I will provide the solution, but I will explain you that how you can attempt a new type of question too. So without any delay, let's get started. Before we start, let me introduce myself. My name is Vishvadeep. I have written the gate exam multiple times and this is my rank in 2010. Before that, I have written the gate exam in third year also. Rank was 682. Apart from that, I am having some ranks 440, 119 and so on. Masters, I went for my masters to IISc Bangalore. Another masters I went for from BITS Pilani in data science, and this is the experience I am having. These are the courses which I am taking on Unacademy's platform. So if you guys are learning and if you guys are seeking for learning, there are so many opportunities we are providing for you guys to learn, of course for free. There are so many live sessions we are conducting on this particular channel. You can attend all those live sessions live so that you can learn in more effective way. One more options you have to learn for free is Unacademy's platform. Go to unacademy.com or download Unacademy's learner app and search my profile. If you search my profile, follow my profile over there, and what you will get over there is special classes. The special classes are absolutely free classes for you guys. You can attend my all the live classes and you can attend my previously taken live classes in the recorded mode also. You can listen and you can learn from there. What is the next live classes I am going to take? Today I am going to take 4 p.m. and in that I will be talking about previous year gate questions on computer organizations, and that too very specific questions which have been asked in the previous years. If you want my all the previously taken classes in more organized way as a playlist, then you can go to this URL and then you can check out. You will get some previously done questions, some theory sessions, some revision sessions, and there are so many other sessions which I have taken on Unacademy's special classes. You can access all those for free. If you need any kind of unlock code for the special classes, then you will use a code VDEEP10. This particular code will unlock your special classes access on Unacademy's platform for free. Use the code and get the unlock the special classes for free. If you guys are seeking for a test series, then we have started a free test series also. Enroll for this test series and solve the quality questions in this particular test series. If you are seeking for last moment boost in your preparation for gate 21, or if you are an aspirant who is going to appear in gate exam in 22 or 23, for all those members I would like to comment on one particular thing, and that particular thing is, as soon as possible, if you will go with the better preparation, you will definitely get a higher chance to give the gate exam with the better way. So again I am telling you, if you are waiting कि जनवरी में ज्वाइन करेंगे, फरवरी में ज्वाइन करेंगे and so on, don't wait for anything. Start preparation now only. Whatever is going to happen any case. If you are waiting for your exam or some event or something, don't wait for anything. Start preparation now. Parallelly you can do any other thing easily. Start preparing now and don't waste your single minute also in your preparation, so that in the maximum available time you can prepare maximum amount of syllabus with the maximum intensity. If you want to join the best kind of preparation, then you will join Unacademy Plus. You should join Unacademy Plus. What is Unacademy Plus? Unacademy Plus is a platform where we provide you the best type of learning in the best possible way, in which you will be getting live classes which are so interactive that you will not get any kind of problem in learning, plus you will get maximum learning out of it, just because every time a small doubt also you have, then all those doubts will be cleared during the classroom. Then all the doubt sessions will be conducted, so that if in the revision or if in the revisit of the topic you get any kind of doubt, all those doubts will be solved. Plus you will be having weekly tests, so that you can learn that okay, whatever you have learned in 1 week, how you can apply that particular knowledge on problem solving, so that you can learn how to write the exams and tests, and ultimately your preparation will be really great. Apart from that, we will provide you so many daily practice problems, so that you will be practicing a lot in the same platform. You don't have to go here and there for any kind of thing. This Unacademy Plus subscription you can take. If you want, then you can go with this particular code VDEEP10 and you will be getting discount. If you want a discount, then you can use this particular code VDEEP10. This particular code will give you discount, of course. Apart from that, using this particular code will give you a connection. What connection? The connection between you, your preparation, is with my team's effort. There is a team, that particular team I am leading right now, and this particular team is giving you preparation of all the courses of GATE Computer Science. So if you want that connection to be established, use this particular VDEEP10 code and you will have a connection directly with my team and with your preparation, so that you will always have a going. If you don't want to take headache or getting the strategies and so on so forth, then you can go for Iconic subscription. This Iconic subscription has all the facilities of Unacademy Plus extra facility of personal coach. What personal coach can give you? Personal coach will take all the headaches from your end to that fellow's expertise. So what that person will do, that person will prepare the strategies for your preparation, will prepare the study planner for you, which is personalized and customized for you, will prepare the study booster session for you, will give you the personalized test analysis. Very important. Why? Just because until you learn from your mistakes, you cannot improve. To improve, you should first be able to smart enough to understand your problem. Sometimes you can't understand your own problem. That's why you should seek the help of an expert, and that particular expert will be the personal coach provided to you in the Iconic subscription from Unacademy side. So if you want to go for that Iconic subscription also, you can go with that Iconic subscription using the discount if you will be using this particular code VDEEP10. So use the code and you will be getting the discount, plus you will be getting other benefits, plus you will be getting my mentorship too. All those benefits in the single subscription, in the single code, this one VDEEP10. And of course, I will be helping you, mentoring you in your entire preparation, so that you can target the exam with the most effective way. So if you got the information, now I want your excitement, your enthusiasm, your very energetic, very young energy, so that we can start the session. So if you are ready, let me know, so that we can start the session. Welcome everybody, welcome. If I haven't given you the warm welcome, then again I am saying very welcome. Good morning, good afternoon everybody, and let's start the session. Are you ready? Type down in the comment box you are ready, and then we will start the session with the first question, this one. The following known to be pre-order, in-order and post-order sequences in a binary tree. Fine. But it is not known which one is which. Means three traversals are given, but which traversal is which one is in order, which one is pre-order, which one is post-order, we don't know. Pick the true statement. Okay, so if you guys know this particular thing, this is very easy thing. Look at this. This is very easy thing. This particular in my classroom also, in my regular classroom training also, and this particular thing is this key. When we have pre-order traversal, first symbol is root. So suppose if this one is pre-order traversal, first symbol M is root. If M is root, in post-order traversal, root is the last symbol. Root is the last symbol. If root is the last symbol, here do we have M? Here do we have M? No. We don't have M here. Means this cannot be pre-order. If suppose second one is pre-order, K is the root. Do we have somewhere K here? Yes, K here. Means yes, second one is pre-order. And post-order is first one. Just because K is the last symbol which is root. And this is in order, remaining one. Like this way, we can identify. Now if we have identified this one, now first and second are pre-order in order? No. Let's check it out. Let's pick the correct statement. First and third are pre-order, post-order. First one is not pre-order, wrong. Second is in order, and but nothing more can be said for someone. No, second one is not in order, of course. D option, second and third are pre and in order. Yes, D is correct one. Somebody has given the answer also. Aditya, really good one. Good thing. Really good. Amazing. Another question. See, so such kind of question, very easy. Why? Just because we know the very basic concept of the tree data structure. Okay, fine. Next question. Another question which is very easy. What it says? A binary tree with n greater than 1 nodes has n1, n2 and n3 nodes of degree 1, 2 and 3 respectively. What does it mean? What does it mean? We know that usually the degree means the children. But here they are talking about degree 1 also, 2 also and 3 also. So in the binary tree we cannot have 3 children. Means the degree definition they are having different. Degree का definition कुछ तो अलग है. What is the definition they are having? The degree of a node is defined as the number of its neighbors. Number of its neighbors. So if we have a tree like this way, this particular node is having degree 2, one this one and one this one. Fine. This node is having degree 2, one this one and this one. Neighbors means in the neighbor I'll have to include the parent also of the node. Also, what I'll have to include is parent also of the node. I'll have to include the parent also. Fine. Now, if you understood this, what exactly they are saying is n3 can be expressed as. We don't know as of now that n3 can be expressed as what. One thing for sure you can do is you can create some example and based on that you can give the answer. How? Suppose this is the example I am having. Okay, this is the tree example I am having. First of all, check out that how many number of nodes which are having degree 1. Degree 1 means this particular node is having degree 1. This particular node is having degree 1. 1, 1, 1 and 1. These 4 nodes are having degree 1. 4 nodes are there which are having degree 1. Now, this node is having degree 3. This node is having degree 3. So, n3 is equal to 2. And how many nodes are having degree 2? This one and this one. This one and this one. n2 is equal to 2. What can be said for n3? n3 is equal to exactly n2. Fine. Not given in the option. n1 minus 2. Yes, B option seems correct. B option seems correct. n1 plus m2 divide by 2. No. n1 plus m2. n1 plus n2 which is 6 divided by 3. No. n1 plus n2 6 minus 1 5. No. So B option seems correct. B option seems correct. But can we get the same answer using some kind of mathematics? using some kind of mathematics, some kind of conceptual understanding. If we can do that, then that will be amazing. So all the nodes having degree 1 and 2 and 3, all the nodes are included in that. Yes. Can I say nodes with degree 1 plus nodes with degree 2 plus nodes with degree 3, number of nodes with degree 1 plus number of nodes with degree 2 plus number of nodes with degree 3 is equal to total number of nodes. Total number of nodes. Yes. Correct or not? Correct or not? Yes or no? Yes or no? Yes, yes, yes. Now, if you know the handshaking lemma, if you know the handshaking lemma of the handshaking lemma of the graph, what it says, sum of degree of all the nodes, sum of degree of all the nodes is equal to twice of number of edges. Yes, sum of degree is equal to 2 into number of edges. Fine, fine, fine. Now, sum of the degree. How much? How many degree? How many degree? Number of nodes are n1 and each node is having degree 1. Right? Right, right, right. Right or wrong? Right or wrong? So n1 number of nodes with degree 1. So total degrees 1 plus number of nodes n2 and each node is having degree 2 plus number of nodes are n3 and each having degree 3 is equal to what? 2 into number of edges. In the tree, we know that number of edges is equal to n minus 1. So can I write 2 into n minus 1? Yes, we can write. Now this particular equation becomes n1 plus 2n2 plus 3n3 is equal to 2 into number of nodes. Number of nodes is equal to this, n1 plus n2 plus n3 minus 1. Okay, let's expand this one more. N1 plus 2n2 plus 3n3 is equal to 2n1 plus 2n2 plus 2n3 minus 2. Fine, 2n2 to 2n2 gone. 3n3 minus 2n3, it becomes n3 is equal to n1 will be subtracted from here, n1 minus 2. Get the value of n3 from here, n1 minus 2. So mathematically also we have proved that B option is correct. Or you can draw multiple 3-4 trees in which you will be having some number of nodes with degree 1, some number of nodes with degree 2, some number of nodes with degree 3, and you can solve the question like that way. Both will be fine. जो भी आपको ठीक लगे दोनों सही है. Clear? Is that clear or not? Is that clear or not? Should we go for the next one? Should we go for the next one? Okay, let's go for the next one. Next one is little bit variation in the same one. So previously whatever given, this one, based on this, we are having something more. A binary tree with n greater than 1 nodes has this, same, exactly same. Previously, whatever they have given, exactly n1, n2, n3 nodes. n1, n2, n3 nodes of degree 1, 2, 3. Fine. Now, next is what? Starting with 1 above tree. Okay. While till there remains a node V of degree 2 in the tree, add an edge between the two neighbors of V, then remove V from the tree. Means suppose in a subtree, suppose we have such kind of node, this one, which is having degree 2. There is a node V of degree 2. What we need to do is we need to add an edge from both the neighbors, between both the neighbors of V, and then remove V from there. Remove V from there. So I have removed that particular vertex which is having what? Which is having degree 2. By doing what? Removing the vertex by adding the edge between the two neighbors directly. Now what is the question they are asking? How many edges will remain at the end of the process? How many number of edges will be there if we will remove all those vertices which are having degree 2? हमने सारी vertices को remove कर देना है which are having degree 2 by adding the edge between both of their neighbors. The nodes neighbor के बीच में node edge add करके remove the node. So it's ultimately what? We are removing all those vertices which are having degree 2. All those vertices which are having degree 2, ultimately I am making this key number of nodes with degree 2, I am making 0. So how many number of edges we can have? We know that number of edges is equal to n minus 1, number of nodes minus 1, and number of nodes can be how many? n1 plus n2 plus n3 minus 1. n2 you have made 0, fine. n3 you know, just now you have calculated n1 minus 2. So n1 plus 0 plus n1 minus 2 minus 1, it becomes 2n1 minus 3. These many edges will remain. Answer is A. So what you need to do to solve such questions? Here what you had to do is, a number of edges, you know that n minus 1 in a tree. There is a tree, so of course n minus 1 edges. If n minus 1 edges, put the value of n is equal to n plus n1, n2 plus n3. Put the values based on your observation that n2 becomes 0, n1 ka value is same to same, n3 you have already calculated as n1 minus 2. I have put all those values and got the one of the option. Really good question. Yes, of course, it's a good question. Mathematics is involved everywhere, whether it is data structure or DBMS or computer organization or everywhere. Everywhere you will get the mathematics. So mathematics is must have thing for you guys. Mathematics is must have thing for you guys. Okay, चलिए आगे बढ़ते हैं. ये रहा अगला question. In a binary tree with n nodes, every node has an odd number of descendants. Odd number of descendants. What is the meaning of descendant? Descendant means node and its children and their children and their children and their children till the last level. Descendant का मतलब क्या है? बच्चे, उनके भी बच्चे जब तक कि लास्ट पीढ़ी, लास्ट जनरेशन नहीं आ जाती. And one more statement they have given. Every node is considered to be its own descendant. Node को अपना भी descendant मानना है. We will consider node to be descendant of its own. And including its own, how many descendants the node is having? Every node is having odd number of descendants. Right? So if we include a node and if we will have odd number of descendants for that node, which means excluding the self, even number of descendants should be there for every node. अगर खुद को इंक्लूड किया है डिसेंडेंट्स में तो बोला है कि ऑड नंबर ऑफ डिसेंडेंट्स होने चाहिए हर एक नोड के. बट अगर खुद को इंक्लूड ना करें, इफ वी विल नॉट इंक्लूड द सेल्फ नोड, द सेल्फ ओन नोड, देन should I say, can I say this, that the node is having even number of descendant? एक descendant कम हो जाएगा. Even number of descendant means what? The children are even, children के children are even, children के children are even, which means the tree becomes a full binary tree. Full binary tree means the node should have either 2 children or 0 child. You can check it out. If this is a full binary tree, you can check it out. You can see every node is having odd number of descendant based on the definition of the question. This node is having one number of descendant, its own. This node having one number of descendant, its own one. This node is having three descendants, 1 2 3. This node is having five descendants, 1 2 3 4 5. This node is having seven descendants, own 2 3 4 5 6 and 7. So number of descendants will be odd including self, will be even if you will exclude self. In that case, every node should have either 0 child or 2 children, which is a full binary tree example. And in this particular case, how many number of nodes the tree is having, which is having exactly one child? Answer is A, 0. एक भी चाइल्ड नहीं होगा, एक भी चाइल्ड नहीं होगा ऐसा, या एक भी नोड नहीं होगा ऐसा जिसका सिंगल चाइल्ड है. देयर इज नो एनी नोड विच इज हैविंग सिंगल चाइल्ड इफ वी कंसिडर दिस पर्टिकुलर गिवन स्टेटमेंट. आई होप यू गाइज अंडरस्टूड दिस. आई होप आपको ये समझ में आया होगा. अनदर क्वेश्चन, वी हैव अनदर क्वेश्चन. वी आर गिवन a set of n distinct elements, okay, different elements, right? Okay, so suppose n is equal to 4 and distinct elements are 1 2 3 4, fine, and an unlabeled binary tree with n nodes. So tree is also given, tree is also given of n nodes. So n equals to 4 node का tree given है. Suppose I have taken this particular tree given. So one tree is given, I have taken any of the tree you can take of 4 nodes. So two things are given. This is given 4 number of nodes, distinct values, and 4 node binary tree is given. In how many ways we can populate the tree with the given set so that it becomes a binary search tree? I need to put 1 2 3 4 values here in this particular tree so that the tree becomes binary search tree. How many ways are possible? How many ways are possible? Can you try down? Can you try it down by yourself? Try करके देखो कितना ऐसे ways possible हैं. Okay, now listen. Let's try to do this. Two things are given clearly. Elements are given 1 2 3 4. A tree is given. I have taken 4 node ka tree, n nodes tree. Now I need to put these values in the tree so that the tree becomes BST. I can put this value 2 here, 1 here, 3 here, 4 here. If you know the binary tree, if you know the binary search tree definition, then binary search tree says that for the root, for any node, left subtree contains lesser values, right subtree contains greater values. That's the binary search tree. Now the trick here is, the question says that a tree is given. When a binary tree is given and we need to just populate the values in a single binary tree so that the tree becomes BST, there is only one option. There is only one way to populate the keys. There is only one way to populate the keys so that the tree becomes binary search tree. अगर ये binary search tree नहीं given होता, if they will not give binary search tree, then there are n factorial ways. There are n factorial ways in which you can provide what? In which you can provide the, or you can populate the keys. n factorial ways say you can populate the key in a single structure, but just because they are talking about binary search tree, there is only one way to populate the keys. And this one is why? Just because they have given a tree. अगर tree given नहीं होता, if they will not give the tree, they will say that n distinct elements create binary search trees. How many binary search trees you can create? Then answer will be D. Answer will be D. You know why? Just because different types of structures with n distinct elements or n nodes you can have is this much, and within each structure, within each type of tree, you can have only one way to populate the key. So for that question, how many distinct binary search trees can be constructed or formed using n distinct elements? Answer should be this, but just because they have given a tree in this particular case, my answer should be 1B. क्लियर टू एवरीबॉडी? सब लोगों को क्लियर है? छोटी छोटी चीजें हैं जो आपको ध्यान रखनी है एग्जाम में. यस्टरडे ऑल्सो आई टोल्ड, जो पूछा गया है, जो रिक्वायरमेंट है, उसके अकॉर्डिंग आंसर करेंगे. हम मन से कुछ नहीं लिखेंगे. ठीक है? ओके, गुड 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 गुड, नाइस, अमेजिंग. नेक्स्ट, what this question says: the height of a tree is defined as number of edges on the longest path in the tree. Number of edges means root to root height is, single node height is 0. Why? Just because root to root there is no any edge. That's why single node height 0. Then if we have further nodes, then height we will calculate based on the number of edges. The function shown in the pseudocode below is invoked as height of root to compute the height of a binary tree rooted at tree pointer root. Fine. So I am calculating the height of the tree using this function. What is the appropriate expression for two boxes B1 and B2? So here is the box 1 B1 and here is the box 1 B2. Fine. Now, how do you calculate height? How do you calculate the height? You calculate the height recursively like this way. So suppose I am calculating height h. So first of all, recursively you calculate height of only left subtree hl. Recursively calculate height of right subtree hr. Now you need to check that which one is maximum among those. If here is the maximum, then entire h will be hl plus 1. Plus 1, why? Just because this node also you need to include in the height. So up to this level you need to calculate, starting from this level to the downside, what is the height of left subtree and what is the height of right subtree. Height h will be equal to maximum of hl comma hr plus 1. That will be the height of my entire tree. This is how you calculate the height. This is how you calculate the height. Now, next, let's try to understand what they have given now. So I know how to calculate the height. Let's see how they are calculating and how I can map my understanding to this question. So you have calculated height, or you have called height for tree pointer n. Okay, n is equal to null, then return -1. So if you have called for the empty tree, then return -1. Yes, we know that. If suppose tree is not empty, then what we will do? We will check out ki if n ka left child is null. If n ka left child is null, means only through the right subtree we will calculate the height. So look at this. Look at this. We are checking out if right subtree is also null, then tree is having only single child, return 0. Suppose first option is this. If node's left subtree is null, right subtree is also null, then what is the height of this particular tree? Height of this particular tree is 0. Same thing we have done here. If left subtree is null and right subtree also null, then we will calculate the height as 0 and we will return it. So return 0 and done. Now next thing is what? Next thing, if suppose left subtree is null, go inside, right subtree is not null, then else case. If right subtree is not null, means you have the tree like this way, left subtree is null but right subtree is not null. अगर right subtree null नहीं है, so my tree's height will be based on my right subtree. Just because left subtree तो anyway empty, right subtree is having some nodes, yes, so my height of the tree will be based on the right subtree. So what exactly the height of this particular tree? Height of this particular tree will be 1 plus height of right subtree. 1 plus height of right subtree, that will be the height. Why? Just because left is null but right is not null. So what should be the box B1? What should be the box B1? So box B1 should be equal to 1 plus, return 1 plus height function call with t's right child. Call height function, with t is right child, calculate it recursively and return 1 plus, so that you will be getting the height of the tree. I hope this is fine. So where I can get 1 plus height of n right here, height of n right plus 1 here, means A and D are probable answers. A and D are probable answers. Let's go here in the else part of this if. If left is not null, then in the else part means left subtree is present. If left subtree is present, you will calculate left subtree's height is equal to h1. h1 is left subtree's height. So third case is this one, ki you are having a node, its left subtree is not null. So if left subtree is not null, you have calculated h1 as the left subtree's height. You look at this, h1 is equal to height of left subtree. Now you are checking that if right subtree is present or not. If suppose right subtree is null, if right subtree is null, then my height of the tree will be based on only left subtree, क्योंकि यहीं पे ज्यादा nodes है, तो height of my entire tree will be h1 plus 1. h1 height of the left subtree plus 1 if right subtree is null. But suppose if right subtree is also not null, we have already calculated h1 and right subtree is also not null. Look at this particular example I am talking about. I am talking about this particular condition. Right subtree is null, no condition is false, else part. Then we are calculating h2. We are calculating h2 as the height of right subtree. So we have calculated height of right subtree in h2. What should we return? What should we return? We should return as height equal to what? Batao bhai. H should be what? Maximum of h1 comma h2. That's it. That will give me height. Maximum of h1 comma h2. No, plus 1. Why? Just because ये नोट को भी तो include करना पड़ेगा. Got it? Got it or not? समझ में आया या नहीं? समझ में आया या नहीं? So what we have seen here, if n का left null नहीं था, then we have calculated in else part height of left subtree in h1. Then we have checked if n का right is equal to null, then अगर n का right null था, then we will return h plus 1. But if n का right null नहीं है, then in the else part we will calculate h2 is equal to height of right subtree. Now we will return what? Maximum of left subtree and height subtree, left subtrees and right subtrees height plus 1. So 1 plus max of h1 comma h2 we will have to return, and the box B2 should be this one. 1 plus maximum of h1 comma h2, which is option A. So A is correct one. A is correct one. Got it? Please confirm, did you get it or not? चलिए, बहुत अच्छी बात है, बहुत बढ़िया बहुत बढ़िया बहुत बढ़िया. अगर आप समझ पा रहे हैं, वेल एंड गुड. अब बात करते हैं अगले प्रश्न की. अगला क्वेश्चन है बहुत 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 सिंपल. व्हाट इट सेज, consider a rooted n node binary tree represented using pointers. फाइन, हमको तो वही पता है कि हाँ, पॉइंटर की हेल्प से ही हम ट्री को रिप्रेजेंट करते हैं. द बेस्ट अपर बाउंड ऑन द टाइम required to determine the number of subtrees having exactly 4 nodes is how much? Having exactly 4 nodes is how much? Okay, now the question seems tricky, but the solution is very very easy. I need to find out such kind of nodes in the tree which are having 4 nodes in the subtree. Okay, I will explain. पहले example लेते हैं. Okay, look at this. So suppose this is the tree. This is the tree. Now. Okay, थोड़ा सा और बढ़ा लेते हैं इसको. In this particular tree, I need to find out. I need to find out that how many such kind of nodes are there which are the root of subtree, and those subtrees are having 4 number of nodes exactly. चलिए इसके लिए देखते हैं. Do this particular node is the root of such kind of tree which is having 4 nodes? No. 4 से ज़्यादा है. 1, 2, 3, 4, 5, 6, 7, so many. So this is not. This one. Is this the root of that subtree which is having 4 number of nodes? No. More than 4. 1, 2, 3, 4, 5, 6, 7, so many. This one to single node. This one, no, more than 4. This one, 1, 2, 3, no. This one, no, only 2. This one, no, only 1. This one, no, only 1. This one, no, only 1. This one, 2. This one, 1, 2, 3, 4, yes. So green लगा देते हैं इसमें. This is the node which is having root of that subtree which is having 4 children, or four nodes in that subtree. Similarly, this one no, this one no, this one no, and this one is yes. Correct. So there are two nodes. There are two nodes in this particular given tree which are the root of those subtrees which are having exactly 4 nodes. Now they are asking, we need to find out all such nodes. We need to find out all such nodes, such 4 subtrees which are having 4 nodes in the tree. How much time it takes? How much time it takes? ठीक है, आपको करना क्या है? आपको परफॉर्म करना है प्री ऑर्डर. What you need to do is perform pre-order. How you will perform pre-order? You will perform pre-order like this way. Start the node. So traverse the node. After that, count in the left subtree how many number of nodes are there. Count the number of nodes in left subtree. Then count the number of nodes in the right subtree. And after that, okay, let's make it as post order. ज़्यादा आपको आसानी से समझ में आएगा. You need to do the post order. So first of all, calculate the number of nodes in the left subtree, then calculate the number of nodes in the right subtree of the root, and then check out if number of nodes in the left subtree plus number of nodes in the right subtree plus 1 क्यों? खुद को भी तो इंक्लूड करेंगे. अगर ये इक्वल टू 4 हुआ, then yes, this is the node which is having subtree of 4 nodes. If not, then doesn't include that in my special list. So what I will do, I will call for this one first. I will calculate recursively number of nodes in the left subtree, recursively number of nodes in the right subtree. I will include number of nodes in the left subtree plus number of nodes in the right subtree plus 1 this one, and I will check out ki total count 4 hai. If yes, then this is my special that kind of node, otherwise not. And how will I calculate the number of nodes in the left subtree and right subtree? Recursively. So let's go this side recursively. When I have come here, इसके लिए भी same करना पड़ेगा. Left subtree is number of count, right subtree is number of count, and calculate, and then return at the end. And if number of nodes are 4, then yes, otherwise return the number of nodes total. And what is this particular type of function is? Call for left, call for right, and some function calculation, which is constant time operation. Yes, this is a constant time operation, traversing kind of thing. And it's a post order. Yes, if it is the post order, then post order traversal takes big O of n time. How much time post order traversal takes? Big O of n time. So if algorithms complexity is big O of n time, then can you compare this with this? If you will compare this with this, A value you will be getting as 1 and B value you will be getting as 0 log of n to the power 0. so that you will get 1. Something to the power 0 is 1. And hence a plus 10b कितना हो जाएगा? 1. Answer is 1. So this seems to be tricky question, but it is very easy if you understand the recursive approach on the tree. Recursion अगर आपको समझ में आता है ट्री पे तो बहुत आसान हो जाएगा इस टाइप का क्वेश्चन. And again, I told you multiple times, please go and watch my lecture of recursion in the tree in the data structure playlist on the same channel. Once you will go through that particular lecture, you will understand that how to interpret the recursion on the tree. ओके चलिए अगला क्वेश्चन ये रहा नेक्स्ट 2015 का क्वेश्चन है. देयर आर वेरी फ्यू क्वेश्चन लेफ्ट, सो लेट्स क्विकली फिनिश दोस क्वेश्चंस एंड द ट्री डेटा स्ट्रक्चर क्वेश्चंस विल बी डन. वंस दीज विल बी डन देन वी विल सॉल्व द क्वेश्चंस ऑन द बाइनरी सर्च ट्री BST, so that those questions along with parallelly with our data structure playlist, once we will study BST, then we will solve PYQs, then we will study AVL tree, then we will solve PYQs, then we will study hashing, then we will solve all those PYQs and work done. So you will be having both the things along with me. Done are done. चलिए आगे बढ़ते हैं. The height of a tree is the length of longest route to leaf path in it. Length of the path. Length of the path means number of edges. Okay, the maximum and minimum number of nodes in a binary tree of height 5 is what? Height 5. So if suppose you have height 3 or 2, suppose this is the height 2, right? Single node height 0, height 2. Height 2, number of nodes are how many? Maximum 1, 2, 3, 4, 5, 6, 7, which is 2 power h plus 1 minus 1. So with height 5, maximum number of nodes is equal to what? 2 power 6 minus 1, which is 63. And minimum number of nodes how many? 1, 2, 3, 4, 5, 6 and 7. Oh, 6. Why? Just because height 5 single node at each level you will be having 0, 1, 2, 3, 4, 5, 6 and 63. Answer A is correct. Oh, तुम कहाँ चल दिए? Minimum number of nodes height plus 1, maximum number of nodes 2 power h plus 1 minus 1. You can form these formulas instantly also, and if you can remember the formulas, that is also fine. Whichever is good for you, you can do that. But very simple question. चलिए आगे बढ़ते हैं. A binary tree T has 20 leaves. The number of nodes in T having 2 children is. A binary tree has 20 leaf node. Number of tree or number of nodes in T having 2 children is. We know that number of leaf nodes is equal to number of internal node with 2 children plus 1. Leaf node given 20. Number of internal node we need to calculate. Answer is 19. That is a simple explanation we have. This is a handshaking lemma. We have already discussed this in the classroom training too. And based on the same type of question, another question we have of 2015, another set. Now this time leaf nodes are given as 200. In this particular case, I2 will be how much? Number of internal node with 2 children. Exactly 2 children. How many? 199. Good. Nice. Super. बहुत बढ़िया. चलिए. Another question. What it says? Consider the following new strategy for traversing a binary tree. Visit the root, then right subtree, then left subtree. Means it's a pre-order traversal, but converse pre-order traversal. What is converse pre-order traversal? Converse pre-order traversal says that we need to traverse the right subtree first before left subtree. That is the root, then right subtree and left subtree recursively. Fine. The new order traversal of expression tree corresponding to the reverse Polish notation expression is. So this is the expression given. We need to construct the tree, and based on that we need to give the converse pre-order. This is the post order. And we need to calculate converse pre-order. Now look at this. In my classroom training, I have explained you this कि reverse of converse pre-order traversal is post order traversal और post order traversal का reverse होगा converse pre-order traversal. Right. So reverse Polish notation is nothing but postfix notation, and postfix notation is nothing but post order traversal of the expression tree. Post order traversal of the expression tree. So either you will go with the long approach. Long approach means you will go with the regular approach, first draw the tree and based on that calculate the converse pre-order traversal, or you can take a simple understanding or a simple observation which I have given in the classroom, that post order traversal ka reverse will give you converse pre-order traversal. So take the reverse of the given expression and you will get converse pre-order traversal, which is minus plus 1 star 7 6 exponent 2 minus 5 star 4 3. Match whichever option is matching, that's the correct answer. You don't have to solve anything in this particular question. कुछ भी solve नहीं करना है आपको. Option is C. Very good afternoon everybody. Very good afternoon. Now listen, this is what which will give you more marks. If you say I know every single thing, I can solve every single question in GATE, I can solve every question of previous year GATE question, I can solve every question here and there and everywhere, but still if you are not able to get more marks in your test series, or still if you are not getting more marks in any kind of quiz or test or exam, then this is the problem. Problem is what? If you can solve a question in just seconds, if you can understand the trick behind the question, if you remember, if you know the small detail of such kind of things in the exam or not, which makes a lot of difference in your problem solving in GATE exam. If I will give you 8 hours to solve all those 65 questions of GATE, of course you can score more than 60. Everybody can score that. But if I give only limited time 3 hours, just 3 hours, can you solve the same number of questions with more than 60 marks? Then that's a big question over your ability. So that particular ability you need to improve. That how you will solve the questions quickly in the less time. And that is what most important. So I always urge everybody to understand each and every topic to the maximum depth, so that you will never face any kind of problem in the problem solving and you will solve the questions quickly with the less time. ओके चलिए आगे बढ़ते हैं. अगला क्वेश्चन, ये थोड़ा सा टफ क्वेश्चन था बट बहुत ही अच्छा क्वेश्चन था. इट इंक्लूड्स द मैथमेटिक्स. Let T be a full binary tree with 8 leaves. Fine. And what is a full binary tree? They have given the definition. A full binary tree has every level full. So 8 number of leaves and every level is full. Means this is the tree. 8 number of leaves. This is the full binary tree with 8 leaves. Suppose 2 leaves A and B of T are chosen uniformly and independently at random. Fine. So you have chosen what? 2 leaf nodes A and B. Fine. So you can choose any leaf as A, any leaf as B, uniformly and independently. Fine. The expected value of the distance between A and B in T is what? And what is the distance? The number of edges in unique path between A and B. So what is the expected value? First of all, expected value is nothing but summation of the value x into probability of x. Summation of the value and its probability. So first of all, what kind of probability, what kind of value of distance you can have? Let's check it out. Let's check it out what kind of distance you can have between leaf to leaf. Okay, so let's say you can have distance 0, fine, might possible. You can have distance 1, distance 2, distance 3, 4, 5, 6, 7, 8, so many distances you can have. Let me first draw a simple thing. Fine. So suppose you are having distance 0. If you have chosen A here and B here, both the leaves you have chosen same to same. If you have chosen A here and B also same to same, distance is 0. If distance is 0, how many occurrences of such kind of A comma B you can have? A comma B, you can choose this one, 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 and this one. So occurrence will be how much? 1, 2, 3, 4, 5, 6, 7, 8. So what is the probability of this distance? Probability of this distance is 8 divided by something. Total number of occurrences. That we will see later on. Fine. Can we have distance 1? How many occurrences are there in which we will choose two leaf nodes A and B, and we will be having distance 1. Suppose if we take minimum distance A and B, A here and B here, in that case distance will be 1 and 2. Edges, number of edges in the path, 1 and 2. So distance 1 is not possible, probability is 0. Then next distance is 2. Let's say if distance is 2 possible or not. Yes, possible. If we take A is here, B is here, distance is 2, 1 and 2. We can have reverse also, right? A here and B here. Yes. So 2 possibilities for this 2 leaf nodes. Then 2 possibility of this 2 nodes. 2 possibility of this. 2 possibility of this. 2 plus 2 plus 2 plus 2. 8 possibilities are there. 8 occurrences are there in which the distance can be 2. So probability of occurrence will be 8 divided by something. Now distance 3. Can we have distance 3 between two nodes A and B? And both the nodes are leaf nodes? No. Distance 3 नहीं हो सकता. क्यों? If you will choose A here and B here, then to distance 1, 2, 3, 4 होगा. Distance 3 is not possible. Probability is 0. Distance 4 is possible. Let's see distance 4. Yes, possible. 1, 2, 3, 4. So how many occurrences of distance 4? A is here, A is here, B is here. 4. So A is here, B 1, 2. अगर A को यहां रखा तो B 1, 2, 4. Then if we will take A here, then B you can have here 2, 1, 2, and if A is here 1, 2. Total 8 in the left subtree part. Total left 8 in the left subtree part. नहीं समझ में आया? अरे एक बार और एक्सप्लेन करता हूं. You can take A here, you can take B here and here. 2. If you are taking A here, B you can take here and okay, A here, B here, you can take here and here. Means 2 more, 4. Now vice versa. Vice versa means if you are taking A here, B you can take here and here. 2 more, 6. If A you are taking here, B you can take here and here. Total 8. 8 in the left side and 8 in the right side. In the right subtree also you can have 8, A, B, C, D, right? A, B, A, B, A, B. So total how many? 16. Fine. So probability will be 16 divided by something. Now distance 5, of course not possible. Distance 5. Distance 6 do we have? Yes. If we will keep A here and B in the right subtree here of the node, then distance possible 4 or 6. 1, 2, 3, 4, 5, 6 possible. So now B where you can keep? Where you can keep B? You can keep B 1, 2, 3, 4. Similarly for A here 1, 2, 3, 4. Similarly A here 1, 2, 3, 4. Similarly A here 1, 2, 3, 4. Means 16 possibilities. Reverse also possible. Means if you take in the right subtree, if you take in the right subtree A, then you can take B here, A here, then B all 4, then A here, B all 4, A here, B all 4. Total how many possibilities? 32? Yes, 32 possibilities. Do we have 7 or more than 7 distances? No. This is the maximum distance. So occurrence of 32. Total how many occurrences? 8 plus 8, 16 plus 16, 32 plus 32, 64. So what is the probability? 8 by 64 here, 8 by 64 here, 16 by 64 here, and 32 by 64 here. Now what is the expected value? Expected value is equal to the distance value 0 into its probability plus distance value 1 into its probability plus distance value 2 into its probability plus distance value 3 into its probability plus distance value 4 into its probability plus distance value 5 into its probability plus distance value 6 into its probability. 7 and all are 0, 0, 0 probability, so nothing. Can you please calculate this one? Can you please calculate this one? You will be getting 4.25 around as the expected value. 4.25 as the expected value. So this particular question, you will be having such kind of questions in which you have binary tree explanation and you have mathematics also. Okay, I hope this is clear to you. Now this particular chapter is over, 3 topics are over. Now in the next session we are having 7 p.m. today, very special session on YouTube. It's a very important, just because we are going to talk about BST, and apart from that I am having 4 p.m. special class today, Unacademy special class, in which I will be solving COA PYQ from 2013 and 2005. If something clicked in your mind, well and good. If not, then from IIT Bombay, whatever they have chosen as the paper. So COA questions only from 2013 and 5, so that you will be getting an idea that what kind of question you can expect. It's not that you will be having same type of question or something, but expectations are there. So that's why I have chosen these 2 years, 2013 and 2005, IIT Bombay ke previous year gate questions on COA. 4 p.m. special class, free for you guys. You can come and you can attend this particular class. And if you are really enjoying my classes and these fellas classes, this is the team of those members who are working a lot for you guys. So please help with these particular guys. Help these guys with becoming more and more available for all of you. And how you can help? You can share the lectures, you can share the playlist, you can share the videos, you can share the profile links of all these teachers. These are the teachers who have cracked at least one of any competitive exam. कम से कम एक competitive exam के टॉपर ये सब रहे हुए हैं. So this is the team who knows how to write the test and how to prepare for it. Make this particular package as much as popular among all of your friends. If you want all the PDF of the lectures, here is the Unacademy Gate CS channel of Telegram. Here we drop all the PDF and we drop all the announcement of our classes. This is the Facebook page which we are having to be connected with you guys. Join these, follow these, so that you will be connected with us. And apart from that, one more thing you need to do is, if you have friends in other branches, let them know that we have the quality education in the other branches too, apart from computer science. So for electrical, ECIN, recommend this channel. Creatrix for mechanical, civil, Telugu language, this engineering Pathshala for the animation videos, so that you can understand the engineering work in more innovative and visualization. SSC JEE, GS Terminal, and this is your own computer science channel for your own learning. If you are a computer science person, you need to subscribe this channel and you need to share this channel, its playlist and its videos to all of your junior, senior and friends and everybody on your social media. Also you can share these playlists and this particular channel. Every time you come for the classes, please like the session and subscribe the channel if you haven't till now, और ये घंटी बजा दो ताकि आपको हर बार जब भी हम क्लास लेने के लिए आए, आपको हर बार क्या मिले, घंटी बजती रहे, आपके फोन की नोटिफिकेशन मिलता रहे. थैंक यू सो मच फॉर ज्वाइनिंग हियर. Thank you so much. Happy learning, everybody. Have a nice remaining day. We will meet soon. Till then,